Welcome back in lecture series on topic electrochemistry. In last two videos, we have studied electrolysis of molten sodium chloride and electrolysis of aqueous solution of sodium chloride. And today in this lecture, we will study quantitative aspects of electrolysis. Scientist Michael Faraday was the first person who studied the quantitative aspects of electrolysis. And in 1830, he discovered that there exists a relationship between the amount of product liberated at an electrode and quantity of electricity used in the process. And according to Michael Faraday, the amount of substance produced at an electrode by electrolysis process depends on the quantity of charge or electricity passed through the cell. Now see here in this picture, it is an electrolytic cell and electrolyte is there, and in electrolyte two electrodes are dipped. One is connected to positive terminal of the battery, which is called as an anode, and another one is connected to negative terminal of the battery, which is called as a cathode. And when electricity is passed, then what happens? The metallic part, that is metal, get deposited on negatively charged electrode, that is cathode, and non-metal get deposited at a positively charged anode. And also here at each electrode, half reaction takes place. Oxidation half reaction and reduction half reaction takes place. At cathode, reduction half reaction takes place, and at anode, oxidation half reaction takes place. That you have studied in previous lectures. So the amount of the substance deposited at cathode or at anode, that can be calculated if you know the stoichiometry of that half reaction. That means how many number of moles of the reactant or product are involved in that half reaction. That stoichiometry, if you know, then you can calculate what? The mass of reactant consumed or mass of product formed at an electrode during electrolysis. And this can be calculated in 4 steps. First step is the calculation of quantity of electricity passed through the cell. And once you know the quantity of electricity passed through the cell, then second step is the calculation of the number of moles of electron actually passed through the electrolyte. And from that you can calculate number of moles of product formed. And the fourth step, that is, if you know the number of moles of product formed, then you can calculate the mass of the substance deposited. So how that we will see one by one. The first step is calculation of quantity of electricity passed. Now, how to calculate the quantity of electricity passed through the cell? It is denoted by Q. Capital letter Q means quantity of electricity passed during the electrolysis, and it is expressed in unit coulomb. Its unit is coulombs. Capital C. It is a unit of quantity of electricity. And 1 coulomb means what? It is the quantity of electricity obtained when 1 ampere current flows for 1 second. Then the quantity of electricity is 1 coulomb. So we have to find out what? Q quantity. How many coulombs of electricity is passed through the cell during electrolysis. So that can be calculated using the relation, that is Q is equal to I. I means the amount of current passed through the cell, and small t means the time in second for which the current is passed. So if you know the amount of current passed through the cell and the time in second for which this current is passed, then you can calculate what? The quantity of electricity passed through the electrolytic cell, that is Q. So Q is equal to I into T. Then second step is the calculation of moles of electron. How to calculate the moles of electron passed? Now you know that 1 mole of any substance is equal to Avogadro's number of that particular particle. So 1 mole of electron is equal to how many number of electrons? 6.022 into 10 raised to 23 electrons. That is Avogadro's number of electron. And 1 electron, charge on 1 electron is equal to how many coulombs? 1.603 into 10 raised to minus 19 coulombs. This much charge is present on 1 electron. Therefore, on charge on 1 mole of electron, that means 6.022 into 10 raised to 23 number of electrons, how many charge is there, that you can calculate. So charge on 1 electron, that is 1.603 into 10 raised to minus 19 coulombs into number of particles in 1 mole, that is 6.022 into 10 raised to 23 electrons. Therefore, this multiplication comes to be nearly equal to the 96,500 coulombs. So charge on 1 mole electron is equal to how much? 96,500 coulombs. That is charge on the 6.022 into 10 raised to 23 number of electrons is how much? 96,500 coulomb. And this 96,500 coulomb is nothing but 1 Faraday. So 1 Faraday of electricity is equal to 96,500 coulombs, and that is a charge on 1 mole of electron. So when 1 mole of electron is there, then how much quantity of electricity is there? 96,500, and that is equal to 1 Faraday of electricity. So Q means the total charge passed through the cell. So moles of electrons actually pass, that you can calculate by using the relation Q. Q means total charge passed through the cell divided by the charge passed or charge passed for 1 mole of electron, that is equal to how much? 96,500 coulombs. So coulomb cancel, mole electron. So the moles of electrons actually pass is equal to the Q divided by 96,500. That will give you the number of moles of electron. And then you can calculate from this, you can calculate what? Moles of product form. How? That we will see. For that you have to write what? The half cell reaction. And stoichiometry of half cell reaction indicates the moles of electron passed and moles of product form. So see here, for example, this is a reduction reaction, reduction half reaction, and here the copper ions in aqueous medium accept 2 electron and copper is deposited. Now here this stoichiometry of this reaction shows that here 2 moles of electrons are required to deposit or produce 1 mole of copper from 1 mole of copper ions. So here the 2 moles of electrons are required for the production of 1 mole of copper, and therefore you have to calculate what? Mole ratio. And how the mole ratio is calculated. Mole ratio is equal to moles of product formed in the half reaction divided by moles of electron required in half reaction. Now in this reaction, number of moles of electron required is 2 and number of moles of product form is 1. So mole ratio of for this particular reaction is equal to how much? It is equal to half. Mole ratio is equal to 1 by 2. That means mole ratio is 0.5. So like this you can calculate the mole ratio and from the stoichiometry of half reaction. And once you know the mole ratio, you can calculate the number of moles of product formed, and that is equal to what? Moles of electrons actually passed into mole ratio. And you know that moles of electron actually passed is equal to Q divided by 96,500 coulombs per mole electron, and that is into mole ratio. That gives you what? Moles of product formed. And moles of product, that means moles of Q means, you know that Q means I into E divided by 96,500 into mole ratio. So if you know the current in ampere, time in second and mole ratio, then you can find out what? Moles of product form. And once you get the number of moles of product form, you can calculate the mass of product. You know that relation N is equal to W divided by M. That means what? The mass of product W is equal to moles of product, number of moles of product into molar mass of product. And moles of product is equal to what? I into T divided by 96,500 into mole ratio into molar mass of product. That will give you what? The mass of product. Now if two cells containing different electrolytes are connected in series, and suppose same quantity of electricity is passed through them, then what happens? What is the relation between the weights deposited at the respective electrode? That we will see from this. Suppose here the two electrolyte solutions are there. Two different electrolytes are there and two cells are connected in series. One is AgNO3 and another one is CuSO4. In this cell, copper sulfate is an electrolyte, and in this cell AgNO3 silver nitrate is an electrolyte. So two cells containing different electrolytes. These are connected in series. And if same quantity of electricity is passed through these two cells, then the masses of the substance liberated at an electrode, that means here silver deposited at the negative electrode and the copper deposited at negative electrode, in negative electrode of the two cell. This can be calculated using the relation, that is W is equal to Q divided by 96,500 into mole ratio into molar mass. Using that relation, we can find out the masses of the substances liberated at electrode, respective electrode in the two cell, and the relation between the masses of the two substances which are connected in series. So for first cell, suppose W1 is the mass deposited, and then W1 is equal to Q divided, same amount of electricity is passed through both the cells. So Q divided by 96,500 into mole ratio of the first cell and into molar mass of the substance which is deposited in the first cell. Then W1, if you rearrange this, then you will get what? W1 divided by mole ratio into molar mass is equal to how much? What? Q divided by 96,500. And for second cell, suppose here mass of the substance is W2, then W2 divided by mole ratio of the half reaction in second cell into molar mass of the substance in second cell which is deposited, and that is equal to how much? Q divided by 96,500. That is what? Therefore, the W1 divided by mole ratio of the first cell into molar mass of the first substance is equal to how much? W2 divided by mole ratio of the second cell and the molar mass of the substance deposited in second cell. So this is the relation between the two masses deposited at respective electrode in the two electrolytic cell which are connected in series, and same quantity of electricity is passed through both the cells. Then W1 divided by mole ratio into molar mass is equal to W2 divided by mole ratio of the half reaction obtained by half reaction, stoichiometry of half reaction, into molar mass of the second substance. That will give you what? The relation between the masses of the two cells. So if you know the molar mass of one substance and the mass of the substance and mole ratio, then you can calculate, and also you know the molar mass of the second substance, and if you calculate the mole ratio from stoichiometry of the reaction, you can calculate what? The mass of the product deposited, that mass of that particular second substance deposited in the respective electrode using this relation. So thank you for watching.